Hi students, now we are going to solve the multiple choice questions in the chapter Electrostatics, MCQ number 1. If charge Q is placed at the center of the line joining two equal charges Q, the system of these charges will be in equilibrium if Q is equal to, that is the value of small q we have to find out. So Q is placed between two similar charges, capital Q and capital Q, placed at points A and B. So let us take the distance of separation from A to B is small x. Since this charge small q is placed at the midpoint, so its distance from A is x by 2 and B is also it is at a distance of x by 2. Now when the system is in equilibrium, the net force acting on every charge must be 0. Understand? So now let us consider the charge placed at A. Okay. So the net force acting on the charge Q placed at A is equal to 0. So what are all the forces acting on this charge Q placed at A? So it is experiencing a force due to small q. It is also experiencing a force due to capital Q placed at B. So I will take a net force acting on the charge Q placed at A is equal to 0. So what is the net force acting on this Q due to these two charges? So that is equal to what? 1 by 4 pi epsilon naught into the force between the charges placed at A and B. So that is equal to what? Q into Q divided by distance square is x square, plus it is also experiencing another force due to small q. So that is equal to what? 1 by 4 pi epsilon naught into q into small q. So q into small q divided by the distance between these two charges is x by 2. So this is x square by 4. Okay, x by 2 the whole square. And this net force must be equal to 0. So I can eliminate the constants and write the remaining term. So q square, q into q is q square by x square plus this 4 in the denominator will go to the numerator. So 4 into capital Q into small q divided by x square, and this is equal to 0. Now once again we can eliminate the term in the denominator. So 4 capital Q small q is equal to minus of q square, minus of q square. Okay. So this q and this power get cancelled. So 4 small q is equal to minus capital Q. Therefore q is equal to minus of capital Q divided by 4. So the value of small q must be equal to how much? Minus of capital Q divided by 4. So which of the options is correct? Option B is the correct answer. Therefore small q is equal to minus capital Q by 4. So option B is the correct answer. Such questions have been repeatedly asked in many competitive exams. So the idea is the net force acting on any one of the charges you consider and you have to derive like this. I hope you must have understood the fine.